we are going to evaluate local max, local min, or global max or global min, or saddle points, whatever are available for this function. So let's proceed first by finding the critical points. So for the critical points, we shall evaluate the partial derivative of with respect to x and that with respect to y of this function. So first we use the product rule. So with respect to x, what we get first is negative 2x, okay, and then leave the second factor as it is, and then plus, now we are leaving the first factor as it is, okay, and we will differentiate this by using the chain rule. So by the chain rule, what will happen? The derivative of the exponential is exponential itself, and then times the derivative of this power, which is going to become how much? Negative 2x. So, or we can just bring this negative 2x here if we want. All right. And then we can take this out as common factor. So what remains in here is this negative 2x right from here. And then let's multiply these out. So what do we get? Negative 4x, then plus 4x cubed, okay, and then at the end we get negative, actually not 4x cubed, I'm sorry, 2x cubed, and then minus 2xy square, okay, and then if we simplify it further, what we shall get is this. I'm bringing it down in the second line, that is right here. If we simplify, what we have is that we got negative 6x plus 2x cubed and all that. So this becomes negative 6x once we combine these two. And of course, this stays as it is. And then you have, let's take 2x out as factor 2x out as common. So once we do that, what we shall have is we shall have 3 here, x square here, okay, and 2 has been factored out, 2 is out, and here x is out. So that's what we get. df dy is simplified. Now, instead of showing you the details of all this algebra, I'm just going to write it directly, and then we shall see that how do we analyze it further, okay? So here I brought those second derivatives in for you. So what we will do is that we shall just compute these quantities at our critical values. So at 0, 0, if you look at this, so right here at 0, 0, this is negative 2 e to the power 4. And then I'll have a 3 here. So this is actually negative 6 times e to the power how much? E to the power 4. Okay. And then when you calculate this quantity at the point square root of 3, 0, or let me just take negative square root of 3 first because that's listed before. It doesn't really matter. So what is this going to become then? Negative 2, and here square root of 3 square will be a 3, so I get negative 3. This will be plus 4, so that will simply be NE, all right, and here square root of 3 to the power 4 will be how much? 3 times 3 is 9, times 2 is 18, so I get an 18 here. Then I'll get a negative 27, so that will be, let me write those down. Why am I doing so many things just verbally? So this is 18, here y is 0, so this is going to be 0, and then we have minus square root of x square is 3, and 9 times 3 is 27, and then we get what? We get plus 3, So this whole quantity would be how much? This would be negative 6, 21 minus 27. So this negative 6 times negative 2 is 12. So this is going to be 12e at this place, right? Okay. And likewise, what will happen is if we calculate this here at positive square root of 30, let me see, I don't have any non-even power on x, so this should be the same value, okay, not we here, okay. And in the similar manner, I'm going to write the values of these quantities here at 0, 0, and all these. I'm doing that in a slightly different order, but that's okay. We can just, compute those in different orders, different times when we do that. So now what I have done is this. That is, I have brought, or I have substituted these critical point values in these quantities. And now let's go ahead and determine where we will have our local max, min, and saddle point, or saddle points, depending on the values of these quantities. So let's use the second derivative test as I just mentioned. So in our question, we have this. Let's calculate it at our first critical point, that's 0, 0. So what we shall have is, we shall have this negative 6e to the 4. That's the value of this quantity at 0, 0. And then the value of this factor at 0, 0 is how much? We will have actually the same thing. Same thing means similar thing. Here this changes to what? This changes to 2. And then we have minus 0 square. Let's not worry about calculating it, because all we care about is whether this is positive or not. So it is positive, so we are good to go. And if we do this, if we look at the second partial with respect to x at 0, 0, that is negative. So this is going to give us a local max, all right. And then likewise, let's just go for the other quantities, okay. And first I'm going to go for negative square root of 30. So what do we get here? So when we look at it for negative square root of 30, first we have this 12e, then we have 4e, and then then we have this quantity is 0 anyway. Sorry, this quantity is 0, okay. At 0, oh no, I didn't calculate this quantity at the other places, but still notice this, since y is 0 and I have y coordinate at 0 in these places, that will become 0 here as well, okay. So this is 0 square. So again, this is a positive quantity, so we are good to go. And if we look at the second derivative at negative square root of 3 and 0, we have that as positive, so we will have a local min there, okay. And likewise, we will have a local min at a positive square root of 30 as well, okay. Now let's get our values. So here, this is the function. These are the critical points. So if we substitute 0, 0 here, what do we get? We simply get this portion is 0. This will become 0. So that will be 2 times e to the power how much? E to the 4, okay. And then at square root of, and then at this point, which is f at square root of negative square root of 30, what we shall have is this, I'm sorry, okay, here, okay. So that is going to be square root of 3 square will be 3, and this is a 0, so I'll simply get a negative 1. And then what will I get here on the power on e? 4. Square root of 3 square is 3, so that is a 1. Y is 0, so I get a negative e. Likewise here at the other place, since all the powers on x and y are even, we get negative e. So here we have this for local max, this for local min, and this for local min. Now I just came to MATLAB just for curiosity or verification of answer. So I did this. I just put the codes in, which I'm putting in the description, and that is, how they look graphically. So here, what I have done is that I have kind of, made the graph close to the local min points, because here it's not that easily visible. So let's just make so you can see right here we have our max, okay, and then here we can see our min along the line y equals 0. But as I said that I did this instead, I went ahead and looked at these more closely, that is, took them in a different window. So what that will do is that will show us more prominently actually that what the local mins are. So here you can see we have rather a min right here at negative square root of 30, and similarly you can verify it at the other point. All right.